So now we try to understand what actually happens in semi-enclosed basins, something that we call an estuary, okay, or a bay. What happens? In order to understand so-called co-oscillation tides, let's start with seiches. Let's start with a closed basin. Okay, you have a tank and fill it with water. And what you can do is you can create a special type of wave, which is actually known as a standing wave, where you have a node in the middle and the water level just swings up and down on both ends. This is shown here in this little sketch. And your first exercise actually dealt with such wave. Okay, what's also shown here is the water movement. Okay, so what actually shifts water from the left to the right side and back are actually horizontal currents. Okay, you get that, and you push water against the side of your tank, and that creates this motion. Okay? And you can actually work out exactly the period that creates these type of waves, because we're talking about long waves. Okay, we're long waves where the wavelength exceeds the water depth by. Okay? And this brings you to so-called Merian's formula, where it's the basic period of a standing wave in the basin. Okay, and this is the starting point. And this brings us to so-called seiches, which are ocean basins have specific periods related to such standing waves. So let's have a look at what happens next. Instead of a closed basin, we're talking about semi-enclosed basin. A semi-enclosed basin, which means it's a region which is on one side connected with the open ocean. So now I have a little simulation for you. So how can you create a strong response in a semi-enclosed region? You get a strong response if the node is located close to the entrance. Let's see what happens then. I have a little animation here. Okay, so you have a tidal wave in the open ocean. You have the node close to the entrance. And what you can see here is that the water is moved in and out of your estuary. The node is located near the entrance, but you get a maximum response at the end. Okay, so for a specific length of your semi-enclosed region, you get a maximum response at the end. I also like to note is that you can also have so-called higher harmonics. Instead of having one node in your basin, you can create two nodes or three nodes or so on. Okay, this links to higher harmonics, but anyway, okay, it's not so important. Okay, so this is what we call co-oscillating tides.